To understand sequencing in and jobs in two machines, let's take an example. Here, two machines are there, machine number 1 and machine number 2. Machine 1 can do cutting operation and machine 2 can do drilling operation. A job entering machine 1 would undergo cutting operation, and after leaving machine 1, it would enter machine 2 and will undergo drilling operation. This table here shows different types of jobs and the time it takes to undergo machining operations in machine 1 and 2 respectively. Handling time is considered 0 in these type of problems. Now to find the order or the sequence, we apply Johnson's algorithm. Its primary objective is to find an optimal sequence of jobs to reduce make span, that is the total amount of time it takes to complete all jobs. It also reduces the amount of idle time between the two work centers. This technique requires several preconditions. First, the time for each job must be constant. Job times must be mutually exclusive of the job sequence. All jobs must be processed in the first work center before going through the second work center, and all jobs are equally prioritized. Now the Johnson's algorithm is divided into 4 steps. Step 1 is listing the jobs and their times at each work center. In step 2, select the job with the shortest activity time. If that activity time is for the first work center, then schedule the job first. If that activity time is for the second work center, then schedule the job last. And in case of ties, you can break the ties arbitrarily. In step 3, eliminate the shortest job from further consideration. And lastly, in step 4, repeat step number 2 and step number 3, working towards the center of the job schedule until all the jobs have been scheduled. Let's understand this with the example we have taken. The shortest job activity corresponds to machine 1, so it will be scheduled first. The next shortest job activity also corresponds to machine 1, so it will be scheduled second. The next shortest job activity is present both in machine 1 and 2, so we will schedule the job activity of machine 1 first and job activity of machine 2 last. Again, the next shortest job activity is in both the machines, so we will schedule accordingly. So finally, the sequence that we will get is job number 4 followed by job number 6 followed by 5, 1, 3 and 2.